guys, let's review how to write piecewise functions. So we've done graphing piecewise functions. We're now going to flip what's going on. You're going to be given a piecewise function, and we need to come up with the actual equations and rules that make it a piecewise function. So what we're really looking at is we're going to have an f of x, and we're going to have a series of equations with rules for this piecewise function. Now, when I look at this piecewise function, I see one piece here, one piece across the bottom, and one piece going upright. So I'm going to have three total pieces to this piecewise function. You can always have more, you could have less if you want that. So the way I kind of work is I'm going to work from the left side, this left equation, down to the bottom, and then I'll deal with this right one. I always work left to right when I'm writing out my pieces. So if you notice, all three of these pieces are linear functions. So when I write the equations, I'm really going to follow y equals mx plus b to help us get down these equations. So a quick reminder, m is our slope, so we're going to find some slopes, rise over run. The b is our y-intercept. Additionally, you're going to see on here we have some open and closed circles, which as a refresher, remember, inequalities that are less than or greater than, those are going to be open circle, and less than or equal to or greater than or equal to are going to be our closed in circle. So I'm going to have to deal with that as well. So starting with this leftmost inequality, I'm going to zoom in here a little bit. I'm going to start by trying to figure out my slope by looking closely and just counting rise over run. So I'm going through the grid here. I'm going down 1, 2, 3, down 1, 2 over 1, down 1, 2 over 1, down 1, 2 over 1. Since I'm going down, it's going to be negative, and I went down 2 over 1, or negative 2 over 1, which simplifies to just a negative 2, which is going to be my slope, x. The only thing I need to figure out is if this trend were to continue on forever and ever, what would be my y-intercept? Well, if I kept going, I would go down another 2 over 1, and I would cross right here when y is 1. So negative 2x plus 1 is going to define this first piece of my piecewise function. The next thing I need to do is I need to talk about the inequality that tells me how I just get this piece only. And we're writing the pieces and the inequalities, we're focusing entirely on the x's. Okay, we don't care about restricting the y, we're restricting the x. So if you notice, and I'll kind of take you through how I go about writing these inequalities, my graph starts in an open circles and goes to the left. So my graph goes to the left, so what I'm going to do is I'm going to start off by writing my x on the left side. Okay, if my graph would be going off to the right, I would write my x on the right side. If my graph is in the middle, which you'll see here in a second, I'll put my x in the middle. So I'm going to start by putting my x on the left side. The next thing I need is I need a number here to help define this rule. Remember, we care about the x only. So at this point right here, I need to know what is x when my piecewise function begins here. Well, that is when x is negative 1. So I'm going to put that on the other side. So I got a left side, I got a right side. The only other thing I need to figure out is what is the correct inequality I'm going to use. And I'm going to use always, I don't need to really worry about these two, and you'll see why in a second with the way I set these inequalities up. I need to figure out am I using less than or less than and equal to. Since it's an open circle, I'm just going to use a less than. So the inequality I just set up says x is less than negative 1, which means I want all the x values that are smaller than negative 1. So like right here, x is negative 1. Right here, x is negative 2. Right here, x is negative 3. Right here, x is negative 4. So those are all the x values that are less than negative 1. Next piece, this horizontal segment right here. Now it might be tough to remember how to write the equations of horizontal lines, but it's pretty simple. You're just going to have y equals and then some number. More specifically, that specific number is going to just be what is your y-intercept. So if this horizontal line continued on forever, I could see I would cross the y-axis at, looks like, 2. So my second piece is just going to be the equation f of x equals 2, which is the same as y equals 2. I now just need to define the inequality to make this an actual piece for my piecewise function. You'll notice my graph is in the middle of two endpoints. So what I'm going to do is I'm going to start by putting my x in the middle. Graph in the middle, x in the middle. On the left side of my graph, this point represents when x is -1. So I'm going to put a -1 on the left side. On the right side, this represents a point when x is 3. So I'm going to put a 3 on the right side. Next, I just need inequalities that open up to the right. I just need to pay attention to open and closed circles to get the correct one. On the left side, it is a closed-in circle. So I'm going to use the inequality less than or equal to on the left side. On the right side, it is an open circle. So I do not need the equal to, I just need a less than. What this inequality says is I need all the x values that are greater than or equal to -1, but also less than 3. AKA, I need the numbers from -1 and up to but not including 3. So this is x is -1. This point here would be x is 0, x is 1, x is 2, and all the way up to but not including x is 3. That is my second piece. The final piece will be this piece over here. So again, it looks like a line. I'm going to use y equals mx plus b to help me out. I just got to figure out the pattern here for the slope. So it looks like starting here we go up 1, 2, 3 over 1. 1, 2, 3 over 1. So really I have a positive 3 over 1, which is just 3x when it comes to the first part of that equation. The only thing I need to figure out is what is my b, what is my y-intercept. There's two ways you could go about doing that. One way is you just work with the slope here. We were going up 3, right 1, up 3, right 1. To figure out my y-intercept, you just do the opposite. You could go down 3, left 1, down 3, left 1, down 3, left 1. Another easy way is if you have a straight edge or your ID, you can line it up and just kind of see, well, what would happen if I would have continued this graph on forever? Lining it up, I would hit this point down here, which is when y crosses at -6. So my equation is 3x minus 6. Okay? Now I just need to set up the inequality part to truly make this a piece for my piecewise function. If you notice, my graph starts at a point and goes to the right. So it starts at a point, goes to the right. Since my graph goes to the right, let's put an x on the right. Now we need to define our number. This point, I just need to know the x value for this coordinate. So this point happens at when x is 1, 2, 3. This is when x is 3, so I'm going to put a 3 over here. Finally, we just need to use the correct inequality based on the open or closed circle. So it is a closed circle, I'm going to use less than or equal to. So what we have here for the third piece of my piecewise function is the equation y equals 3x minus 6. And I want all the x values that are greater than or equal to 3. X values that are greater than or equal to 3 would be 3, would be 4, would be 5, would be 6, would be 7. So that is writing a piecewise function. I hope this quick little review helped you out.